of class 10 chapter reflection and reflection. Today I am going to discuss about what is mirror formula. Mirror formula is the relation between object distance, image distance and focal length of a mirror, which is calculated from pole of that mirror. That relation is like this: 1 by u plus 1 by v is equal to 1 by r, where u is object distance, v is image distance, and so also f is focal length. Listen carefully, students. All these distances are calculated from the pole of the mirror. And this is the relation. This relation is the mirror formula. We can calculate very well. U and v is given, then we can calculate f. Suppose you are given focal length and image distance, then you can calculate where the object should be kept to obtain that image on the screen. Again, the distances are different for different spherical mirror. It is object distances remain always negative, but focal image distance and focal length should be different in different spherical mirror. That is in different in concave mirror and also in convex mirror. Let's discuss about the sign convention, which is very important for you to do problem solving. Sign convention. To understand the sign convention, maths is very important. Spherical here is a rectangular coordinate system. We all know about rectangular coordinate system. Now this is x and it is O and it is x dash. Above origin it is y and below the origin it is y dash. Below the origin it is negative, above origin it is positive of y axis, and right of the origin it is positive and left of the origin it is negative. Wherever we talk about object distance or image distance or focal length of any spherical mirror, the mirror should be kept within origin of the rectangular coordinate system. Let's suppose here is a spherical mirror, concave mirror. We all know about the concave mirror. What is concave mirror? It is the reflecting surface. Those mirror are known as concave mirror. The reflecting surface are bent innerwards, right? The reflecting surface of this mirror is innerwards. It means suppose an object is kept here. That is AB. Size of the object is this. AB is the size of the object. We can say it is height of the object, that is h. H is always positive, as because size of the object or height of the object is positive because it is along positive axis of y. It is along the positive axis of y. That is why height of the object is positive. We can take as positive. And it is pole. And the distance from I have already discussed that the object the distances are always calculated from pole of the mirror. Suppose the object is at point P. This distance between the pole and in object is u. Object distance is always negative. Object distance is always negative. That is, u is object distance, and it is always negative. No matter whether it is a concave mirror or it is a convex mirror, it is always taken as negative. And suppose say the object is at A and the image is formed at the same point, and the image is formed at the same point B dash A dash. The distance between image to the pole, this distance is V. In case of a concave mirror, image distance is negative. V should be negative. Image distance, and it is negative. And the focal length, suppose the focus is here. F. F is also sorry, I am going to write here. Use this portion of the whiteboard. Focal length is always negative for a concave mirror, but it is not always like this. Sometimes it is different. When object is placed between focus and pole, then concave mirror will form a virtual image, and the image will be behind the mirror. In that case, image distance will be different. Image distance will be positive. It is become positive, right? For concave mirror, all this information is very important to solve a numericals relating to the mirror formula. To understand this, you can use a rectangular coordinate system as like this. Okay. Another factor, students, I am going to teach you another factor, magnification. Magnification is very important also. Magnification is also a very important factor. Magnification is what? Magnification is just a ratio. Magnification is just a ratio of size of the image to the size of the object. That is, suppose magnification is denoted by a letter, small letter m. M is equal to size of the image is, suppose say h dash, and size of the object is h. For real image another thing you should remember closely, for real image, for real image, for real image, magnification should be negative. Magnification should be negative, and rest of the images of partial image it is become positive. But in general, concave mirror produced a negative magnification for real image, but when the object is placed between focus and pole, it magnification will become positive, as because there will be a partial image, partial and erect image, and size of the image will be enlarged. It means size of the image is larger than the size of the object. I hope this video will help you to understand the sign convention of mirror formula. Okay, students, and use this pattern to resolve numerical, which is important to score in your examination also. Okay.